1990-91, Senator Glenn introduced legislation that for the first time would guarantee workers a lifetime health insurance if they met a risk profile, if they were working around radiation or exposed to beryllium and other nasty substances. You know, you have to understand, in order to make the most destructive nuclear weapons in the world, you had to handle the world's most poisonous substances in large quantities. And the people who were doing that were these workers, and they weren't necessarily being protected. If you don't protect your workers, you don't protect the public. It's that simple. And all of this has been lost on this profession because it was confined in this world of secrecy, isolation, and privilege of the national security imperative associated with the production of nuclear weapons during the Cold War. And we're still sort of trying to recover from that problem.
"15 years after its cleanup, Professor DeGarmo took us on a tour of the quarry.
Okay, here we go. Now here's the haul road.
Okay.
Right here.
So this is the road they use to
move all the materials from
the Weldon site down to here. Okay.
Yeah.
Were there no guidelines as to what you needed to store nuclear waste? They could just say, we'll take this quarry and we'll just use it.
I think it was hit and miss, not necessarily because they were abiding by any laws. But I mean, this makes sense. It's out. It's about, 2-3 miles down from the site. It's a natural quarry, pretty abandoned. We're now into the quarry itself.
And this was all filled in?
This had all sorts of materials in it. It had barrels, it had building pieces. When they did the first remediation downtown in the late 50s, all of those building parts and pieces came out here.
During the remediation of the quarry, crews would drain and treat over 70 million gallons of contaminated water. Bulk waste was removed and driven by truckloads up the Old Hall Road to be placed in the cell. It would take close to 12,000 round trips. Having removed some 120,000 cubic yards of contaminated soil and materials, residual contamination of groundwater remains to this day.
So beneath us is radioactive waste?
Yes.
And we're following you.
Yes, you're following me. Whenever you have the kind of high levels of radioactive materials in any one location, the actual remediation to make it suitable for human habitation is quite extensive. You can do less cleanup, still do a remediation, but not to the degree that would be needed for human habitation if you claim it's a nature preserve. The idea, I guess, is that some of these materials would absorb the radiation. In this case, it's buried low, so it wouldn't be a problem if it wasn't disturbed. And so this is a long policy that, not only the Soviets used, but, the United States seems to have adopted as well. And a lot of these sites that should probably undergo further remediation, they don't have to because of the nature preserved quality.
Unfortunately, some of these materials have not stayed put. They have migrated into the groundwater beneath and beyond the walls of the quarry.
It's a pretty bike ride.
It's beautiful. But I mean, if you just don't know what's going on and you're riding your bike and you didn't look at the little placards, I don't know that I wouldn't know what these, I've seen these all my life and I've never known what they were till I started doing this work. And now I'm thinking, my God.
They're everywhere.
They're everywhere.
Well 1007, one of the many monitoring wells the Department of Energy has drilled to track the movement of these materials. A 2011 report on Weldon showed that over the last decade, Many of the monitoring wells have far exceeded the targeted goal of 300 picocuries per liter. Some hitting levels as high as 1,219, 1,286, or even 2,776. Samples taken from the pumping wells in the St. Charles well field from 1991 to 2001 showed gross alpha levels exceeded the standard of 15 picocuries per liter 3 times. Finished water samples that went to the public from this time frame were within the EPA's guidelines. After the passage of the Safe Drinking Water Act in 1974, the EPA was required to determine safe levels of contaminants in drinking water. They believed the ideal maximum contaminant level goal for radionuclides, such as gross alpha, beta particles, and uranium, were 0. But enforceable levels, known as maximum contaminant levels, are based on cost and the ability of public water systems to remove contaminants.
We forget. We start, okay, we've cleaned it up now. That's all we worry about. They don't look at the history of that 40 years that it sat there full of stuff, radiating into the community, radiating into the environment around it. The same thing with Weldon. It sat empty for years. Well, we're not worried about that. We've cleaned it up. Well, okay, we may be at less impact now, but what about the people who lived here, worked here all those years? The school that's a mile away sat there within realm of that radiation. It's the whole story, not just a piece of the story. Okay, you came and you cleaned it up. And you got it down to an acceptable level, but that doesn't account for all the damage that was done prior to the cleanup. And that's the history we don't want to look at. We want to pat ourselves on the back for being technologically savvy, saying, ooh, look at what we've done. But we're not taking responsibility for the years prior to that.
The Weldon Spring site would fall under the Department of Energy's Office of Legacy Management. They would set an annual budget of $1.4 million for long-term surveillance and maintenance for an area that could remain hazardous for thousands of years. The Fernald site that succeeded Weldon would become Fernald Preserve after one of the largest environmental cleanups in the nation's history, costing over $4 billion.
One of the most prevalent questions that veterans of North River Depot, also known as Caribou Air Force Station, and military and civilian workers who worked in and around the East Loring weapons storage area during the time the area was active, often ask is, was I exposed to any radiation during my time working there? This program is informational in nature and identifies several transuranic, radioactive elements that were identified during the cleanup of the area, both during and after the base closed in 1994. The Operable Unit of Record of Decision published in August 1995 had identified 7 radioactive waste burial sites at North River Depot. According to the Record of Decision, 5 radiological underground storage tanks, USTs, had been removed in 1994. The Operable Unit Record of Decision published in August 1995 identified several as transuranic elements at the former North River Depot that registered above normal background levels, including the following. Americium-241, AM-241, is an isotope of americium. Like all isotopes of americium, it is radioactive, with a half-life of 432.2 years. Neptunium-237 is a chemical element with the symbol Np and atomic number 93. A radioactive actinide metal, neptunium is the first transuranic element. Neptunium metal is silvery and tarnishes when exposed to air. The element occurs in 3 allotropic forms, and it normally exhibits 5 oxidation states, ranging from +3 to +7. It is radioactive, poisonous, pyrophoric, and capable of accumulating in bones, which makes the handling of neptunium dangerous. The longest-lived isotope of neptunium, neptunium-237, is a byproduct of nuclear reactors and plutonium production. This isotope, and the isotope neptunium-239, are also found in trace amounts in uranium ores due to neutron capture reactions and beta decay. Tritium, from ancient Greek tauro tauomicron, tritos, third, or hydrogen, 3, symbol T or 3H, is a rare and radioactive isotope of hydrogen with a half-life of about 12 years.
I went to a meeting in the mid-1980s. This was during the heyday of the Reagan administration. This is before the appearance of Gorbachev and the beginning of the end of the Cold War. My wife was a member of the Health Physics Society, which are the people responsible for providing protection from radiation in the workplace and to the public, and they mostly work for the nuclear industry, of course, and the nuclear weapons program. And the speaker was this attorney from the Department of Energy, and his speech was radiation, the offense, and the defense. And he basically got up and gave this speech, and the gist of it was he put up a slide, a pyramid, and at the top of the slide was a segment that said compensation. The middle of the slide said radiation standards, protection standards. The bottom side was broken up into 3 segments: nuclear weapons, nuclear power, nuclear medicine. He pointed to the top thing and said, if we start granting compensation to people who claim they were injured by radiation, this is going to force us to tighten our standards. And this will effectively curtail our nuclear weapons deterrent, our ability to expand nuclear power and nuclear medicine. Therefore, you as health physicists should learn to become expert witnesses against plaintiffs in lawsuits. And I am here to introduce you to a Department of Justice attorney to explain to you that we're going to start holding workshops at the different chapters of the Health Physics Society to begin to train you so that you go in courtrooms against workers and members of the public who are seeking damages for harm that might have been caused by radiation. It gave me an insight into the this entrenched bureaucratic culture of how they operate, where they drew the lines here. And if you went outside those lines, that was a career-ending gesture.
It just always seemed real tragic to me that men and women that worked in these facilities over the course of World War II and the Cold War, and even up till current times in some locations, were put in these facilities unbeknownst to them being exposed to radiation and a ton of other toxins and chemicals that would cause illnesses or cancer. It's 2 different stories. If it's the spouse, then they almost to a T, will say, my husband didn't talk about work. I have no idea what he did. All I know is I made him a lunch, he went to work, and he paid the bills. The workers that were and are still alive to talk about it, I think generally it was a job. And in some sense, they were being told that they were, especially the people in the World War II era, they were being told that it was a patriotic job and it was a necessary job for the war and the Cold War. And that era of men took that seriously. And because of that, they were honorable men doing an honorable day's work.